So, welcome, back, sort of from the keynote, but yeah, thanks for making it here. This is a much different and much more specialized session, so don't expect continuity from what I told in the keynote. This is a different focus on very much the heart of what we call core container in Spring, namely injection points and bean definitions. So we're actually going, it's a little bit hardcore, you could say, from that perspective, as hardcore as anything gets in Springland. But the situation that I commonly find is that a lot of people have a rather basic understanding of how injection points and bean definitions work. And not just the working part, it's not the inner workings that matter that much, it's what you can do to express yourself at the point of injecting another dependency or at the point of defining another dependency, and what that actually means and how the container can react to what you specified. It's basically like a programming language feature. Sometimes you need to be a little more explicit and expressive in what you actually mean, giving a hint, in this case to the runtime container in Spring, in how you want things to be processed. Without any hints, all we can do is to apply default behavior that might or might not match what you actually meant, right? What you actually commonly have in mind. So it's primarily about that, literally about dependency injection, the model. Revisited from a modern day perspective. Modern day perspective means we're primarily going to talk about Spring Framework 6.2 level, the state of the art in Spring Framework 6.2. Most of those things actually have been in there for significantly longer. So at least since 5.3, some of it that I'm talking about is in since like 4.3. And towards more like the end of this session, I'm going to talk about Bean Registrar, which is a brand new feature that just recently landed in Spring Framework 7.0 milestones as a variation of basically the bean definition topic. So towards the end, there's some 7.0 specific part waiting, but everything else is basically there right now for immediate consumption, almost guaranteed to be in the Spring version that you're currently using. Right, so with all the subtitling here, there's quite a few ways of doing things in Spring. Traditionally, we think about dependency injection being an annotation-based concern. You're basically expressing yourself through annotations at the injection point and at the definition point. That's not actually the case. The core container is not annotation-based. It's based on bean names and bean definition metadata. And that's going to shine through every now and then. So we're going to talk about the annotation way of doing things, but also in particular about programmatic ways of doing things and the combination thereof. Because in many cases, it is totally fine to use an annotation-based declaration at the injection point, but then to interact with the container through, for example, object provider as a programmatic handle. So there's also ways of combining this. It's not great. There's a lot of gray. It's not black or white, right? It's not annotation or programmatic. There's middle ground here. All right. So let's get into let's start with something very basic, right? What we call an injection point, just to clarify the terminology, is basically an argument that you mean to be provided by the runtime container. For example, if standard dependency injection for constructors, a single constructor argument, that's a single injection point. You want the container to call this constructor and to resolve the data source for you, the data source bean usually, to be injected here. That's what you effectively mean. There could be several such injection points. So if you have like a constructor with multiple arguments, every single one of those arguments is its own independent injection point, just to clarify the terminology. A little hint in here, we used to enforce add autowired for injection points. We thought that adds to the readability and just clarifying that this is an injection point containing handle here. We actually dropped that for constructors. So if it's an obvious scenario, like a single constructor to be resolved, then you don't need to do an add auto-white here at all in any recent Spring version. I think we dropped that in 4.3. The common case doesn't even have an annotation here then, right? You just declare a constructor with an argument. Okay, one more thing. Semantically, what you mean here, or what you effectively say here, is in order for my repository to be constructed, for an instance of this bean to be constructed, you need a data source bean that's fully initialized to be provided to the constructor. Semantically, right? Without saying anything extra, that's what the container goes with as an assumption. A fully initialized data source that you could immediately use. You could use it in the constructor, right? It's ready, it's fully configured, and it went through the bean initialization lifecycle in the core container. Unfortunately, in practice, that's not what you usually actually need, because think about common constructor-based injection. What are you going to do most of the time? You're going to take this reference and store it in a field. You're not going to immediately use it in the constructor. So that semantic can be a bit off and can lead to early initialization sequences that are not actually ideal. But we can't resolve this without a bit of extra help, right? But yeah, before we continue with variations of injection points, something also rather obvious, you can put injection points at the constructor level. For example, for a component scanned bean found in the class path. In the more flexible case, you actually usually have a configuration class with a factory method, an add bean factory method, that's equivalent to a constructor. The Spring Core container, the Spring programming model largely makes factory methods as equivalent as possible to calling a constructor for that class. So this is sort of, think about it as a constructor equivalent. Instead of calling the my repository constructor directly, we rather call a factory method. As a consequence, the factory method can have the injection points. Just like the constructor would take the data source, the factory method takes the data source. Even if the factory method does then return new my repository passes in the data source into the constructor, then it's kind of obvious that it's just a bridge into the constructor, but a factory method can do more, right? It can call builder APIs, it can do other things in addition to the constructor call. So much for the constructor versus factory method case. More importantly, for the purpose of the rest of this presentation, both of those are injection points. The data source argument here is just as much of an injection point, the same kind of injection point, as the argument on the constructor was. And for further purposes, we're going to not vary between constructors and factory methods all that much. Further variations we only look at here for the factory method case. So coming back to the problem that I sort of hinted at before. Just like with this constructor and this factory method, both of them effectively, semantically require a fully initialized data source to be passed in, even if you're not actually interacting with the given data source reference quite yet. Even if you're just storing it, the container will, by definition, make sure that it's fully initialized when passed in. You can suggest to the container that you're not going to do this. You can ask for a lazy reference. That's the add lazy annotation for injection points. There's also add lazy for definition points with a different semantic. Add lazy for an injection point. This is for a particular argument, right? Remember, the injection point is actually the argument, the parameter, the method parameter, a single parameter. If there's more than one parameter, everyone is independent. So if you inject two data sources here, a data source 1 and a data source 2, you could have one of them lazy and the other not, right? So every injection point is independent. This data source here has an add lazy marker, which basically is sort of a programming model construct, telling the container that you do not intend to immediately interact with that data source. that it's okay if it's, first of all, not fully initialized yet, possibly not even fully initialized during the bootstrap, but that's a bit of an independent concern. For the injection point, this only means that at the time of calling this factory method, the data source does not have to be fully initialized. And that opens up a lot of potential. Think about concurrent bootstrapping, think about circular references, right? So by saying that you don't need this to be fully initialized yet, you're giving freedom to the container to optimize things, to optimize the bootstrap sequence. So what do we actually do at runtime here? You still ask for a data source, right? The parameter type passed in here is data source. So what the container has to do here is it creates a proxy. Think about AOP style proxy. It's a lazy initialization proxy of type data source of the same type that behaves lazily on method invocation. So you actually don't get the target data source. You get a proxy for the data source, a transparent proxy for the data source. For every call on that data source, it's going to resolve to trigger resolution of the actual target data source and then forward the call. You're not really seeing this. It still looks like a data source to you. But that's what you get, right? And that's how the lazy reference behavior comes in. Another variation, and we're talking about a combination of a couple of things later on. Look at the signature once again. These are parameter level annotations, right? It literally annotates the parameter, the data source parameter. We use the same thing for nullability, and we also semantically take it into account. So nullability is not a totally new topic, and I'm not showing inputs here, so you're not seeing which kind of nullable annotation this is. It doesn't actually matter. This could be the Spring nullable annotation, this could be the JSpecifier annotation in Spring Framework 7. Doesn't make a difference for what we're talking about here. You annotate the parameter as nullable. Every one of those parameters can independently be nullable or non-null, right? There's a non-null by default assumption in Spring's nullability model, both in Framework 6.2 and Framework 7, same policy, right? Just a different set of annotations, but same policy. So what do you actually say here? For a regular, plain data source scenario, like this one, you actually insist on the data source to be present, right? There's a bit of a lag here, I'm sorry. Yeah, so for this one, you actually insist on the data source to be there. You need it, it's mandatory. The container, the bootstrap sequence is supposed to fail if the data source cannot be resolved. You don't say so anywhere, it's the default semantic, right? With nullability, we basically allow for the injection point not to be resolvable. You're basically saying, I'm okay if you can't resolve the data source for me. In this case, please call me with a null value. And I'm going to take it forward from there. Maybe there's some defaulting that you do, so use some other connection pool, whatever, right? This is in particular useful for your own components. I'm using data sources here as kind of a common thing that's injected, but you can obviously do this to any component types of your own, where you're saying, if a bean of that type is present in the application context, give it to me here. If it's not, I'm okay with null, and maybe I'm deactivating that functionality or just passing that on, and certain things won't happen then, but that's okay, right? You are expressing that through @nullable. You tell the container, basically, you give it a hint. Do I want to fail if it's not present, or do I want to be called with a null value? So, variations of things. For quite a while, we also support Java util optional, the Java 8's optional type. So that's semantically equivalent, basically. If you're not happy dealing with null values, if you'd rather have a sort of a monadic optional type here, then declare javalang optional and of type data source and interact with that optional. You can just say like data source is present, not the ideal way of dealing with an optional, but just for the sake of it, you could say if present, and then there's a lambda expression doing something with the data source. That's, from the container perspective, an equally expressive hint. It's actually a nested type structure. The injection point basically uses a holder type, optional in this case. The actual target type is data source. But the holder type, the optional, semantically implies that the type is not required to be there, right? That it's optional in the general sense of the word. Just like at nullable. But you're not going to get a null value here, you're going to get an empty optional instead, if the data source is not resolvable. Now, getting towards the main point of this section. We have, for quite a number of years, we have a holder type of our own called object provider. That's a quite powerful handle for injection points, allowing you to do many things in a pretty unified fashion. So just like with optional of data source, this is a Spring's object provider type, so it's a Spring-specific type, object provider of data source. So what do you get here? Not the data source itself. You get a container handle that allows you to interact with beans of type data source. And only when the method is called then in the body of the method, you would actually call a method on the object provider. If all you want to happen is resolution of the data source at a particular point that you control, just take the object provider, hold on to it, and at some point of your choice, call getObject on it. That's the point when the data source, the target data source, is going to be resolved and returned to you. So semantically, it's kind of like lazy access. You get an object provider handle, but only, and that doesn't resolve the data source yet, only when you call getObject, it's going to be resolved. So it's a bit like addLazy, an alternative to addLazy. An important difference, there's no proxy involved. It's basically a wrapper handle, object provider of something. You call getObject on it, you get the raw data source. That's not a proxy. So in that sense, more efficient at runtime, less involved in dealing with it. You're actually going to have the target data source in your hands and lazy access semantics with it. Object provider can also test for availability. You can actually check for availability as well, but you can also say, like, give me the data source if it is available, otherwise give me null. That's what getIfAvailable does. You have the target data source in your hands, no proxy, and it's conditional. It's like addNullable, basically. So what we see here is like a combination of addNullable and addLazy. Access at the time of your choice, and conditional based on whether it's present or not. We also have optional-like interaction. You can do object provider if available. The data source is then passed in if it's available, and you can do something with it, reacting to it. Again, lazy access semantics, optionality implied semantically, and Java util optional style interaction with it. So object provider can already do quite a few things, and I'm not even mentioning all of them here. Object provider also has uniqueness resolution if there's more than one data source, and there's a couple of things, right, that it can do in that space. But for our purposes, lazy access, optional access is already pretty good coverage. Let's return to more like standard injection for a moment. We're going to return to object provider as well. So that signature again, but in our case here, it doesn't ask for a single data source. It wants a set of data sources, which means I basically want all beans, all auto-variable beans of type data source. Without any further qualification, that's what it means. And I don't really care about the order. That's what you also say with a set, right? What can you do? Well, you can do whatever you want against that set, right? You can iterate over the set, you can check for its size and do something if there's more than one data source. That would be somewhat common, right? Checking for whether there's more than one, then do something special. And if it's only one, proceed with a standard setup. So whatever you do there is up to you. The set of data source, however, from an injection point perspective, is a pre-resolved collection of data source beans. So once again, you get fully initialized beans injected into this set, all of those data sources. You actually trigger initialization for those data sources with asking for them at the time of the method invocation. There's variations of this. You can declare a list of data source, and you get order behavior for lists and also for arrays. We actually sort them according to the factory order. That's typically coming from an add order annotation on the target bean method, or it comes from an ordered implementation in the target bean itself. So whenever ordering kicks in Spring, it's always the same combination of behavior. That's also what you get here. Pre-resolved data source instances, fully initialized, ordered in that list. And ordering actually only works with pre-initialization because the beans can implement the ordered interface, and the getOrder method on the bean then says what order it is. We can only call getOrder on the instance of the bean, so this naturally implies a pre-initialized target bean. Right, as mentioned, and not particularly interesting as a variation, we do the same for arrays. And again, I'm not showing every variation. You can also inject a map of bean name and data source, but let's forget about it. It's a bit old school and not really recommendable these days. Let's focus on the essence, collections or arrays of the target data source. Switching to the object provider mindset. You're already getting a bit of a hint of the story here, right? Object provider is kind of the preferred way of doing these things. If you declare an object provider of data source, that can be a single data source, as we've seen before. You call getObject on it, you call getIfAvailable or ifAvailable on it. You're basically interacting with the presence of a single uniquely resolvable data source. However, there's also multi-object access on object provider. Object provider is actually iterable, so you can use it in a for loop. You can literally say for data source against the object provider, for every data source being found, here's the body of my for loop, right? And the iteration is even lazy. So we're not going to resolve any of those data source beans before you actually resolve it, before you call iterator. And even the iterator itself is lazy. So the objects are only resolved on the next call. If you abort, if you don't fully iterate, the rest of the beans is not being initialized. Not being forced to initialize. They can be initialized for other reasons, obviously, but the loop itself doesn't force them to be initialized at the time of loop execution. As you might already have guessed, optional style, you can do streams. There's a collection like stream method on object provider where you're asking for a JavaUtil string of type data source against the container, against the current state of the container, which means you're going to get stream interaction like iteration but more flexible and more expressive. You get stream interaction against every data source being present in the context. So for example, you can do then for each in a callback method that says, like, for every data source found, do this, post-configure it, register it for monitoring, do whatever, right? Whatever you need to do against the data source before you continue. And without any further semantic attached, it's, again, lazy. We only initialize the target beans as they happen to appear in the stream. So if you don't fully consume the stream, they are not, the rest of the beans won't be forced to initialize. Think about lazy singleton beans, for example, right? It makes a difference whether you force them to be initialized at that point or not. Now, ordering. So basically the list case. This is sort of the set case, right? So iteration or for regular stream access is basically set semantics. Lazy access set semantics. If you want ordering to be involved, so the equivalent of a list of data source, you can do ordered stream and then do whatever you want to do against the JavaUtil stream, right? So like call for each on it. Slightly different semantic. They are going to be pre-ordered. Pre-ordering requires full initialization of all target elements. So in this case, you're actually forcing all the data sources to be initialized in order to determine their order. And then you get stream API access to it, to all of them. So that's already quite a bit of power in this single innocent-looking object provider handle, isn't it? And it's basically all I want to show. There's a little more. So if you look at the object provider Java doc, it's an interface, right? It has a couple of other methods, variations of these things, tweaking the ordering semantics a bit further and stuff. So there's more you can do, but for the essence of the story, this is it. I'm only going to augment it a little further. Like what happens with qualifiers? So let's return to standard example, object provider example once more. Now adding a qualifier annotation. That's important here because at the object provider level, there is no such thing as a qualifier annotation. You can't ask the object provider to consider a particular object provider a particular qualifier annotation. It is what it is, a type-based handle with lazy access semantics. Whereas here, you're basically saying, I want a single data source, it could be multiple actually, that are annotated with a particular qualifier that you defined. A custom qualifier annotation that makes sense in your code base, in your architecture, and among multiple data sources that happen to be present in your application context, all of them probably having a different qualifier attached, you want the one with a particular qualifier here, generically named myQualifier. Could be any name, it's an annotation of your own, right? An annotation that you declare. With a standard injection point, no object provider, just a data source type, and the qualifier annotation sitting next to it, you're basically saying this argument, this data source argument, plus the myQualifier annotation, that's what I want, right? I want a bean of type data source annotated with myQualifier, and I want a single one, a resolvable single type, single bean of that type. There's other ways of qualification. You can do that strings at qualifier annotation, so you don't need to define one of your own. You can provide a string qualifier using strings at qualifier annotation and providing a string value that differentiates the data source that you want from all the other data sources in the system. So there could be a string-based qualifier attached to every one of your data source definitions, and you select among them by specifying this string name, like my data source here, right? A bean of type data source qualified by the string my data source. That's what you're asking for. That's what you get directly injected. It's a regular injection point, so everything else is the same. Fully initialized data source. When matching the qualifier, it's a fully initialized data source being passed in here. And a variation that might not be so well known or so obvious is that even for a plain data source argument, you can actually rely on certain semantics for the argument name. We call that a dependency name. For a constructor or a factory method, this is just a parameter name. For a field, it's the field name. Here's just an innocent-looking argument of name, my data source. Type is data source, the name is my data source. What does the container do here? If there's more than one data source, and it can't uniquely resolve a single one, it's going to take that name into account. It's going to say, like, among my candidates, is there one with the name my data source? Technically, it's a string-based qualifier, so just like what we've seen before. It's basically this, more concise, and sort of optional. It's okay if it's not qualified, whereas the previous one insists on a qualifier being there in the bean definition that you're asking for. This is sort of optional. If it matters, if it helps, give me the one that's named my data source. So it's kind of a bit of a bonus here. But it can be quite useful since beans have names, injection points have names, express a dependency name. If you're happy aligning those names, this is good enough to select among multiple matching candidates. Right. There's actually a little bit more attached to that just as a side note. In Framework 6.2, there's even an optimized code path if a bean of that name matches the dependency name. So you're even helping runtime performance if your dependency names align with your bean names. Say if you're saying my data source here, and your target bean is also called my data source, that shortcuts the resolution algorithm, makes it significantly more efficient at runtime. So it's again bonus semantics that the container attaches if things align. Not a necessity in the programming model, but a hint for optimizing things at runtime. But going back to the core design problem here, we can express this with object provider again. And how does this work? It's actually quite natural. The qualifier annotation sits within the parameter declaration. So the factory method has a parameter of type object provider of data source. You're actually asking for a data source, but you want an object provider handle. And that parameter is what you annotate. So at my qualifier just sits there annotating this DSP parameter here. And that's how resolution works. So what you're actually going to get is an object provider for data sources that are qualified with my qualifier. You basically get object provider and all of its capabilities, but pre-resolved, pre-filtered for matching data sources with the my qualifier annotation. So there could be multiple. I mean, in many cases, annotations identify a single bean, but you could have multiple qualifiers, multiple data sources, a couple of qualifiers, and several data sources with the same qualifier. That's valid. So that's why you can even do stream access against this if you want. Right? So all of the variations work with object provider. You can do a custom qualifier annotation. You can do a string-based qualifier. In this case, string-based qualifiers don't have to be unique. It's not a bean name. It can be the same as the bean name, but there can be multiple target data sources with the same string-based qualifier. So it even makes sense to assume that you can iterate over this. Right, and last but not least, even the fallback on the parameter name works. You just need to name that argument my data source. It's an object provider of data source, but basically ignore that, call it my data source, and interact with it. My data source get if available, an object provider method that you're calling takes all of this into account. If there's more than one, you can still try to ask for a single resolvable one, and the name of the parameter is being taken into account, just like a string-based qualifier would have been. Right, so much for the object provider discussion. A single type that we're talking about here can do a lot of things, right? So it's a retrieval handle predetermined for a given bean type, object provider of a particular type. Taking the injection point into account, so it even works with qualifiers and stuff. The primary feature is lazy on-demand access. It only resolves target beans when you try to access them, which is at a point of your choice. It allows access and checks against a single matching target bean or multiple matching target beans, including ordering semantics. Note that object provider design-wise is not bound to bean names or annotations. It does not have the notion of a bean name or an annotation within the handle. Object provider is exclusively about type-based checks, single or multiple candidates, otherwise just type-based. No other design concern in the object provider API itself. You can declare it for a declarative injection point, as we've seen on a factory method, on a constructor, wherever. You can also programmatically get an object provider. If you have a bean factory in your hands, in your code, call get bean provider of a particular bean type, like get bean provider data source.class, you're going to get an object provider of data source, the same API. So there's also a purely programmatic way of using object provider. All right. So, so much for a rather deep introspection of what an object provider can do or what kind of variations of injection points you can have. Let's switch over to bean definitions for a further moment. There's many ways of defining beans in Spring, and I'm not going to elaborate on all of them. So it's a very curated choice of things that we're talking about here. Let's focus on configuration classes as the most common case. So what actually happens here, if a configuration class has an add_bean method, is that the container derives what we call a bean definition from it. So it's literally going to go over the add_bean methods, and for every add_bean method, it's going to create a metadata object called bean definition, and it's going to register that internally against what we call a bean definition registry. It knows that the name by default is data source, it's the method name. It knows the expected target type, which is the return type here, data source. It knows how to construct a bean of that type, because it needs to call that factory method, right? That's how it operates. Standard configuration class behavior. In the background, this thing that we call bean definition, you could register that directly. You could do new generic bean definition, set bean class, set factory method name. You could programmatically build that thing and register it yourself. Configuration classes just are a convenient declarative way of this automatically happening for you. So, right. We are now on the definition side of things. We define beans. We don't inject them. We don't request access to them. We rather provide them, right? At this point where we are declaring how to provide them, we can add additional information. And for factory methods, that's additional annotations. You can, for example, add the previously seen add_lazy annotation to the add_bean method. Please note that's semantically different. We are not doing lazy injection because we're not injecting. We are defining the bean. Add_lazy here has initialization semantics of a different kind. You basically tell the container that on a regular bootstrap of the application, it does not have to initialize this bean. It can, but it doesn't have to. So if it's referred to by some other bean, that's okay. But otherwise, it leaves it untouched and will lazily initialize this singleton bean on first access, on the container side of things, not on the access side of things, right? So it can go together. You can have a lazy access point talking to a lazy target bean. That's okay. It's a combination of semantics. Further semantics can come in through qualifier annotations, so we're going to see that in a moment, or very, very common or very practical, I should say, for example, through the add_primary annotation. You might have more than one data source, beans of type data source. You want this one that you're declaring here to be sort of the preferred one. If a single data source is to be injected at an injection point, it's supposed to be this, ignore all the others. That's what add_primary basically says. If all you want is a single data source injected, use the primary one, ignore the others. It's sort of like a qualifier, but not quite. You can also do qualifiers, right? Personally, I would actually recommend doing things with add_primary. In many cases, you don't need qualifiers at all. All you need is bean names, dependency names, and possibly a primary marker. With that, almost every arrangement can be expressed. And yet if you choose to use qualifier annotations, you can add them here. If this my qualifier is found here, it would match an injection point where someone is asking for a data source with my qualifier attached. So it's basically same qualifier annotation for the injection point and for the definition point here. It matches only then if you're using qualifiers. But yeah, the recommended variation would rather be to operate with primary in practice. But yeah, so custom qualifier annotations can also be replaced with Spring's qualifier annotation and a string-based qualifier. So what we've seen for injection points, where someone's asking for a string-based qualified my data source, in order to match that and to define the data source that you want to be provided there, you can add an add_qualifier annotation with the my data source string here. The same way, it's the same annotation, just sits on the factory method. Or you do the same thing that we've already discussed for injection points. You can just name the bean my data source. If the injection point parameter name is also my data source, that's a fallback match. I mean, technically a fallback match, but if you're not using qualifiers, it's just a direct match. Among multiple data sources, it's going to use the one where the name matches. Pretty straightforward, and you need to provide a method name anyway, so why not use it, right? It's also more concise than adding extra information, extra string in a qualifying notation. So this little snippet, say, this is a configuration class that you can just define a couple of beans in. It's a unit of configuration, self-contained. You can combine it with other configuration classes, so we're in standard configuration class territory. You can just register multiple configuration classes for consideration, or you can also put hard import references in there. You can have another configuration class at importing the stuff that you just declared. So your little data source definition stuff, you can import that in a higher level configuration class. Every time someone uses my repository config, implicitly they are also going to get the my database config thing applying. All the bean definitions in my database config are also going to be present to any user of my repository config. So that's actually pretty old behavior, so framework 3 era behavior. Now, that's configuration classes, right? What we do in Framework 7, or what we add as another twist, is a variation of things. Instead of providing a configuration class with an addBean method that defines a data source, you can also provide what we call a bean registrar. This is a callback implementing an interface with a single method, a register callback where you get a bean registry and the standard environment passed in. And against this bean registry, you may dynamically register beans. You basically do the same thing that you do in a configuration class, right? So sort of you express an equivalent arrangement. Look at this configuration class. It's a configuration class defining a data source bean. It's lazy and primary, and it needs to be built with whatever the body of that method has, right? The return new basic data source pseudocode. In the myRegistrar case, you're expressing this programmatically in a functional style, a bit DSL style. You're saying register bean, data source is my bean name, data source is the expected type, the return type of the factory method, more or less, right? And then there's a callback API for customizing this further. You can basically specify semantics. You can add lazy init, you can add primary, and you can add what we call a supplier, an instance supplier, basically a lambda expression for creating that bean. All of this stuff is also being turned into a bean definition object at runtime. So if you then look at the state of the container, you're going to see the bean definition registry, the bean names, sort of the keys, and bean definition objects expressing those semantics. And all of these facilities have been there in the bean definition model already, even instance suppliers. You can define beans that are constructed through a lambda expression for since 5.0, if I remember correctly. This is just a sweet and concise way of expressing that. A registrar doesn't have to be constrained to a single bean, right? So obviously, it's a general callback. You could register any number of beans. Think about a configuration class with multiple addBean methods. Here, the equivalent is a single callback, multiple register bean calls. The sweet spot here is, in contrast to configuration classes, you can actually use everything Java code lets you do. You can do if checks. You can do for loops. You can do complicated availability checks, complicated conditions into that if. So this is pseudocode to some degree, but you may see what happens, right? The data source bean is always registered unconditionally. If statistics available, whatever that is, right, a field, if that says true, we're also calling register bean for another bean that operates against this data source. It's built on top of the data source. It's a made-up DB statistics bean, whatever, right? But it's a typical case, monitoring and that sort of thing may be optional in your setup. And then you're done. This is stuff that you cannot so easily express in a configuration class. In a configuration class, you're basically statically structured. There's a number of addBean methods, every add-bean method creates one bean, defines one bean. That's it. If you want another bean to be defined, add another add-bean method. If you don't want it to be defined, remove the add-bean method, right? Or remove the configuration class where the add-bean method is on. There isn't really a way to say like, I'm conditionally based on local evaluation, I'm going to register this or maybe not, right? There are ways of working around it, like returning null from a factory method. Please don't do this. We sort of regret that that was ever possible. There are better ways of doing this here. If you want to compare it to anything at all, then it would be condition annotations on add-bean methods. But even here, there's more structural flexibility. You can do a for loop. You can register 5 data sources based on some detection. You read some configuration file of your own, a for loop, then you register data source 1, 2, 3, 4, 5 based on what you evaluated. You can do these things here in a pretty convenient and concise way that you can't express in a configuration class at all. A configuration class is too static for that. So previously, you had to do this against the bean definition model directly. It was always possible against the bean definition model, but that's very low level. This is almost as high level as a configuration class, almost as convenient, and giving you a huge degree of flexibility here. Now, in the previous example where you imported the snippet, right? You have a local small configuration class with a data source configuration. You import that into a higher level configuration class. Now, if you have that expressed as a bean registrar, you can do the same import arrangement. Even from a configuration class, you might still have a higher level configuration class that you declare, and you add import this snippet, this unit of configuration that you just built as a bean registrar. So the add import annotation is bean registrar aware. It knows what to do with it. The other benefit with bean registrar is also tooling, right? It's a standardized format of expressing programmatic registration in a self-contained reusable class, your bean registrar implementation. Tooling knows what to do with it. So with all common tooling that we are involved with, we actually make the tooling aware of what the bean registrar does. So in the beans view, in an overview of beans that are going to be present at runtime, common tooling will understand it's in the process of being built so that it understands these register bean calls just like they understand add-bean methods on configuration classes. So you're going to have a unified tooling experience even if you replace a certain configuration class with a bean registrar or vice versa. Right, so that's already everything I meant to say about bean registrars. There's a bit more nuance to things, right? But we don't need to get into the detail. Bean registrars are units of programmatic configuration, self-contained in a class. They can be instantiated, the register method call, and then the registration happens. That's what they semantically mean. They are importable in the sense of add importable into a higher level configuration class. They can also be registered against the programmatic application context setup, like at the very bottom. You can say, I have a generic application context, new generic application context, register this bean registrar. You're going to apply everything that this bean registrar expresses at this point against the generic application context. So like with Object Provider, it is integrated into the annotation-based model, but it can also be used in a purely programmatic model. As already elaborated, there's a lot of structural flexibility. It's just a term for a pretty simple fact. You can use if, you can use for, you can do standard Java code for evaluating a condition. You can do all of these things within a bean registrar implementation. Very naturally, whereas with a configuration class, you're kind of constrained because it's effectively a static class structure that you need to operate against. So that's maybe the primary benefit. That's actually the most important benefit also for the wider Spring portfolio. Bean registrars have been built for other Spring portfolio projects to use them. For example, Spring Security, Spring Integration. They have setup concerns in some of their configuration classes that are much better expressed in a bean registrar than with a convoluted import arrangement for configuration classes. Well, and last but not least, this is AOT friendly. So Spring AOT knows what to do with them. If the Spring AOT run encounters a bean registrar, it's going to generate code that also applies this bean registrar. Through the reusable class that you provide, it can also be reused in an AOT processed setup. Whereas any other programmatic registration code in some main method of yours, Spring AOT doesn't know what to do about it. It needs the structural boundary around it. So it's AOT friendly, it's tooling friendly, it's a sort of building block arrangement. You could imagine abstract bean registrar implementations that provide a couple of things, a couple of template methods, and a concrete subclass makes it complete. So it's also a sort of building block, base arrangement for custom configuration needs, where it might be a better fit than a custom configuration class or an abstract configuration class arrangement. So it's a kind of alternative to configuration classes, domain-specific language style, DSL style. I say kind of because it's primarily meant for certain purposes only. It's meant for common bean arrangements, primarily in infrastructure. Spring integration, Spring security are fine examples there. So if you have a large project setup of your own where some common pieces are provided and consumed by multiple parties or multiple services of yours, bean registers might be a good fit. But generally speaking, we expect the main configuration, the general user configuration of any application to be written as configuration classes. We are not trying to supersede configuration classes here by any means. We're trying to complement it with a reusable unit of programmatic configuration that nicely integrates with the configuration class model for certain purposes. And there's a couple of unique capabilities that add-bean methods have. For example, the qualifier annotation match, the same add-my-qualifier annotation for an injection point and for a factory method. You can only really nicely express this in the configuration class model. Bean registrar isn't made for that at all. There's nothing that you can put the my-qualifier annotation on, basically, right? All right, so much for this little tour through the flexibility and design of some of the injection point options that we have and the definition options that we have with a lookout towards bean registrar in Spring Framework 7.0. As mentioned initially, everything other than bean registrar is available right now in Framework 6.2 and even earlier versions in many cases. So by all means, explore your options there and try to be as precise as possible in what you ask the container to do. So I hope there have been some inspirations in there that you can also use in your existing code bases in particular. Thanks for your attention. And if there are any questions, I'm around, just approach me. Thanks.